I think we are going to go ahead and get started. Welcome, listeners, to Flagship Friday. I will introduce first our panel of moderators and experts today, and then do our Innovation Did You Know fact, and then begin to launch into our special guest today, which is the semiconductor. So let's start with the introduction of our moderators and our guests. I will start with our Nakaya Rucker, who is our moderator for the chat today and to help facilitate questions. Nakaya, can you introduce yourself, please, and advise students about how, and listeners, how to do the chat?
Absolutely. Well, welcome everyone. Good morning or good afternoon now. My name is Nakaya Rucker and I serve as the External Relations Director of the University Library. I'm so excited to be here with this phenomenal group of people. We want you all to participate in this conversation. We're not talking at you all, we're talking with you all. So please be sure to use the Q&A in order to ask questions. Don't feel like you have to hold them until the end. As you provide commentary and questions, we'll be sure to weave those into today's discussion, So thank you so much, and I look forward to engaging.
Thanks, Nakaya. Nakaya has been with our flagship since its original focus and helped us evolve some of that. Our next moderator is Anna Luge from the College of Design. Anna Luge participates in our program in many ways, including as an advisor for our Innovation Fellows program. She is also a spark behind many of our programs. Anna Luge, can you introduce yourself?
Yeah, now that you can see. Can you hear me properly?
Yes.
Oh, good. Okay, super. Hi, everyone. Good afternoon. Thank you for joining us. My name is Anna, and you'll find me in the College of Design, as Karen said, usually attached to things like design thinking, creativity, problem solving. And so if ever needed, please come. We'll find a way to make your idea become something that it's tangible. I am very excited to be here today and with this special guest of the semiconductor. It's very important for the world of design, so I promise that I won't ask tough questions. I promise. Okay, thank you. Welcome.
Great. And then I will introduce Dr. Chen from the college, Associate Professor of the Supply Chain Management in the Ivy College of Business at Iowa State University. And he holds a PhD in Business Administration from the University of Oklahoma and an MBA in Operations from the University of Alabama. He has 8 years business experience in international trade industry in China before moving to the United States. His research focuses on supply chain integration and collaboration, reverse logistics, third-party logistics, and international supply chain and logistics topics. He's published over 40 articles in leading supply chain management and logistics journals, and has co-authored a book and a book chapter that was published by the Financial Times Press and the Oxford University Press separately. He's very involved with industry organizations and is a frequent presenter around supply chain topics in the industry. So we are very grateful to have him here. We also have today with us David Slump. He is our innovator in residence at Iowa State University and co-founder of our Innovation Fellows program. He is also a constant advisor of students and encourager, and has really been responsible for the intellectual and behavioral development of our students as innovators. His second job is president of Global Market Strategy and Services in HARMAN. He serves, again, he works to improve hands-on experience available to students. He and his wife, Christine, have funded and launched the Student Innovation Fund and provided seed funding for student team innovation projects. You'll be hearing more about that Innovation Week, which is April 16th to April 23rd, when we will judge and announce the winners of this year's Innovation Fund Challenge. David also currently sits on the Engineering College Industrial Advisory Council. He's president of Global Market Strategy and Services at HARMAN, a wholly owned subsidiary of Samsung Electronics. David is responsible for leading the overall strategy for HARMAN together with the CEO, HARMAN's overall operations in global markets, and the day-to-day operations for financial performance in digital transformation services. So before we begin our big day and do honor to these wonderful experts, we always have an innovation do you know fact, and I would just like to share, we've mentioned it a couple times, I'm going to go ahead and briefly share my screen. This year, coming up, will be the first inaugural launch of our Ignite Innovation Showcase at Iowa State University. This is 8 days of elevating student innovation, everything from the ride engineering project that does theme park engineering, through arts and innovation, student-produced films, faculty-student collaborations in research innovation, civic innovation. Anna Luch will be leading that day with Nakaya from the library, and including just student invention. We'll be featuring student invention. So I encourage you, the registration is up. Nakaya, you might share that registration in the link. If you register, you will get updates, regular updates about, as we add pages to our website, about what to expect. This is something that you don't want to miss. Okay, so I will go back to our speakers, and I think I'm going to start off with Dr. Chen, because I know our topic is, today we're going to be interviewing the semiconductor, right? It's the biggest brain and biggest innovation influence that we will have probably in our innovation series this year, because it's quite critical and instrumental to all the technology that we have, everything from dishwashers to your game application, right? So, but a critical component, the problem arises less about the semiconductor itself and how it's made, but more about the supply chain shortage. So Dr. Chen, I thought I might start with you. Can you share a little bit with us about what supply chain is and what the impact of these types of shortages and understanding supply chain?
Yes, first of all, thank you very much, Karen, for your introduction. So this is my first time involved with Flagship Friday. Thank you for the invitation. I'm very honored to be on the same panel with David. And then, yes, I do teach supply chain management. The pandemic is horrible, but one thing positive coming out of the pandemic, in my personal opinion, is awareness of the importance of supply chain and supply chain management. But before pandemic, supply chain is a lesser known field, but now in everyday media, we hear supply chain, the word, but on a daily basis from every person, every party. Then, so in general, just using plain words, supply chain management is basically managing all the processes and all the flows of goods and service, from the raw material components to finished final products, and then deliver them to end consumers. So it's not only about the flow, it's also about all the business processes. So, and then the idea is, to streamline the limited resources to create customer value. So every product needs a supply chain. And then today's topic is semiconductor. I want to declare that I'm not a technical expert. I would defer that to David, but it is a very hot topic. I have been following this topic quite closely as a person in supply chain management. And then, so it is a very significant shortage, and then it will have significant impact on a lot of companies. But actually, David, if you don't mind, I will kick the ball to you, and then we can discuss more about supply chain management implications of semiconductor later.
I think that's fabulous. Today's character is the semiconductor, and we are going to delve deep into the character of the semiconductor as our major focus of study here. So, and the perfect person to talk about that character, somebody who knows that character well, would be David Slump. David, can you share a little bit? Can you maybe define semiconductors, and what does that mean to me? Why am I interested in semiconductor?
Well, you alluded to it, Karen, earlier, in that almost every device that we know today has become a smart device. We hear the word of connected or smart. We talk to our microwaves, we have Alexa in our home, we have our smartphones and laptops, we have self-driving cars, and semiconductors are the brain behind this activity. They can range from very sophisticated brains that have a lot of computing power down to very simple microcontrollers. But the fundamentals of the supply chain and the difficulties all roads lead back to the same sources of raw material and processes. And that's good and bad. It's great that more and more products are connected. I think our lives are becoming so dependent on them now. We take convenience for granted, but they don't always show up. And I think most of us probably know if we tried to order anything or walk into the store to buy anything right now, it takes longer to get delivery. Either people are out of stock or it might take a month to receive a new product. And all of this is stemming from constraints in the supply chain because this innovation is so powerful and great.
David, I'd like to know a little bit more about that. Oh, go ahead, Dr. Chen.
No, I didn't say anything.
Oh, I'd like to know a little bit more about that, David. Can you talk a little bit about, this supply chain shortage is very complicated, right? Can you share a little bit more about the supply chain shortage and what the concern is and what the impact is?
So the impact right now is pretty severe. If you open up the Wall Street, I'm sure you've seen automotive companies are adjusting production over this, PC peripheral companies, smartphone companies. It's every company right now is being impacted due to a constraint. So what led to this constraint? Because the whole point of SIOP and supply chain is trying to balance supply and demand so that you don't have these shortages. And this has been an evolution over the last more than a year. But the current issue is really post-COVID. We had a demand flow, demand for products going into COVID, and then everything pummeled, and then things came back. Well, on the surface, you might say, well, everything came back to about the same level, so why are we having challenges? But when you peel through that, it's not true. The industry we're in, automotive industry, has come back to about the same demand, but the ramp of that rebound is fast. And as we'll probably talk about later, these things have long lead times, so ramp rates are quite important. The second is industries that were in decline. How many of you really buy computers versus laptops, or even laptops now versus tablets? So there were declining trends in the industry that have rebounded dramatically due to this work at home. So now, while fundamental demand has rebounded, there's all this new demand. And people can't get out and about, so what do? They use their entertainment devices. They use other things. They're cooking at home more. They're buying more sophisticated electronics. All of this has compounded and flooded a supply chain that has really long lead times. So it's not like turning on your faucet, and if you want more water, you just turn it on and you have instant water. The lead times to add capacity in this industry could be 2 years.
Yeah. I wonder, I do want to follow up with this because you have indicated this is like a multimodal experience, a 3D chessboard, right? And I think that that's a really intriguing image, that because as we trace, why is this occurring? Why is this so complex? And how do we end up here? I'm wondering if you might talk about that.
Yeah, the three-dimensional chessboard. So one is just everything's becoming more and more connected. You can't really think about a device that isn't being powered through either onboard processing or voice and speech. So more and more connected devices are driving demand. What people might not realize is on the other end of every connected device are servers and cloud computing, also driving demand for silicon. So demand is just going up, and these things collect information that drives the demand for memory, and memory is silicon. So it's a compounding effect of these connected devices. The second part of this is the connected geographies. I think we'll show a picture later of just how interconnected the world is, how many trips between, say, the US and China these things take. So this is very much interconnected geographies, part of the reason of these supply chains. And even pre-COVID, these things were being challenged because of tariffs and the concerns around companies like Huawei, I'm sure you've heard in the press. So all of this started to compound and disrupt a supply chain that was set up for a very global connected economy. And then that started to get disturbed. So this is a three-dimensional chessboard, and it's pretty impactful, as you can see. I mean, it's 2.7 trillion in GDP impact and lots of jobs in the United States.
Yeah, Dr. Go ahead. Does somebody have a question? That's probably my echo. Dr. Chen, I wonder if you might comment a little bit on this. This is a supply chain issue. Why is it taking so long to really get our products? And when we order, why has this caused such a great delay?
No, actually, I want to follow up on what David just said, the interconnectedness. So those three dimensions are great. And also, I think, most people, when we see in the news, the shortage for auto chips, we don't realize what causes the shortage of auto chips. So there, as David mentioned, there are a lot of compound factors. In fact, from what I understand is that many other factors. For example, when pandemic happened, most auto companies reduced their forecast for production. So they reduced their order for their chips. And then at that time, a lot of auto chip manufacturers, they switched their production capacity for consumer electronics, consumer electronics chips, because they're way more profitable. And then, as David said, switching the chip manufacturing from one type of product to the other takes a long time. And then, so the auto sales actually unexpected to come back very quickly and strong. So at that time, when they go back to the chip manufacturer, they don't have enough capacity. And then also the extreme weather in Texas impacted a lot on the chip manufacturing because of power outage. And David also touched on Huawei, the Chinese telecom manufacturer. But because of the U.S. ban on a lot of export to Huawei, so even before this shortage, Huawei was stocking up chips in a very large amount of volume, and then that also make this the shortage very more serious. Another thing is Bitcoin. We all know Bitcoin price has risen substantially here, and then graphic cards, which uses the computer chips, and then graphic cards unit sales just skyrocket, and then that also competes with the auto chips. So all of these compound factors putting together, so that's why we have so much more delay. But so from what I read is before the auto chip, the chip manufacturers, their lead time is 13 weeks, but now they're getting to double the lead time. So it takes months for them to deliver the chips. So that's why they cause significant delay in the supply chain.
I think
And
that's
maybe, Karen, sorry, maybe this is a good point to put a little context to this. So, why are we talking about this on a flagship Friday for innovators? And the goal here, as we've talked in the past, innovation requires cross-functional teams. And it's hard to imagine product-related innovation today that doesn't involve a silicon. So as innovators, you probably are thinking about it in terms of, okay, what hardware do I pick? What software works on it? but are you thinking about what if I'm successful in the market and I can't get any of this? So understanding the importance of a supply chain team member was part of the goal here. And then the other part, and why Dr. Chen, I have to give a plug, is I met him, what, 2 years ago, 3 years ago? Time flies. Yes. I was fascinated that he has a class where the students live the supply chain. Okay, not follow it on paper, but physically go through the port of LA, back to the port of Shenzhen, into the plants of China to see what is the flow and what are the complexities. It just so hit home to me that Iowa State's all about hands-on learning and hands-on experience. You can't imagine a better hands-on experience than that. And that's why we thought this was an important topic. You can't really innovate in a connected world without silicon. And this is a pretty long-lived, over the next couple of years, more than likely, problem for the industry.
You know, so David and Dr. Chen, you talked a little bit about impacts on consumer. Yes, it takes me longer to order my refrigerator. So instead of being able to buy a refrigerator off the floor, I have a 5 or 6 month lead time on a refrigerator. I couldn't find a freezer in the entire state of Iowa for 6 months delay. So I'm already experiencing as a consumer some of these problems that we're having. I wonder if you two might speak to the industry. What has been the issue? What has caused problems in the industry in terms of preparing to meet demand and ordering supplies and building your strategic plans?
Daily phone calls with customers. No, I'm not joking. This is normally supply chain. You know, you're set up to be one of those roles where if everything goes well, nobody knows you exist. Okay, it's probably a little like Spencer's job, right? Nobody knows Spencer's doing a marvelous job here running this thing unless something doesn't work, and then we all wonder, hey, what went wrong with the audio or the video? And in companies, it can be thought that that's the supply chain role because everything's set up and so smooth, and then when it's not smooth, you know, you really feel it. And that's what we're in right now, daily calls between CEOs. Okay, CEOs normally aren't talking about chips. In fact, I had a conversation with the CEO today, and he goes, I'm a finance guy. I've learned more about silicon than I ever wanted to know, you know? And that's just the reality of the world because customers are mad, revenue won't be recognized, and it's causing havoc, particularly on the automotive industry, or aviation, or medical devices. These industries have higher requirements. So if we just go through the basic stepping, what's it take to make a chip? You know, most of you probably would recognize one of these if you've ever opened up under the hood of a box, a phone or anything. You see those black die with the little slivers of silver hanging out, okay? But within that is a lot of complexity, but it all comes back to a silicon wafer. So the industry refers to that as the front end process of, you know, putting a lot of devices can come off of one silicon. And to give you a feel of the sophistication of those wafers, one manufacturing cycle of a wafer could be 90 days through a plant. So we're not talking hours, okay? And then we're talking about production employees that have PhDs and masters in chemistry and others. Okay, so this is a very technology intensive process. And those wafers can go into phones or cars. There's nothing at that point yet that is delineating it. But those aren't perfect processes, as you can imagine. So then what's called the back end is cutting those and putting them into the die, packaging them, and then testing them. And in mission critical industries like automobiles, aviation, others, that testing, robustness, and packaging for temperature and thermal requirements takes longer than, say, something that goes in a device that might last, you know, 2 years. And all of that is creating attention. Of course, all of those extra tests have extra cost, and time, which is as Dr. Chen mentioned, some people will shift their production to shorter returns, but then that hurts mission critical industries. And that's why this is in such a hurt. To add to that, we talked about the interconnectedness. The wafer production tends to be in countries like the United States, Taiwan, Japan. The packaging tends to be in China and others. So you're seeing how these things get moved around the world. And you can imagine, if you've also opened up the paper lately, you've probably seen how ports are congested. The LA port is congested. The Hong Kong port is congested. So not only is there a shortage of products, there's a shortage of the capacity to move this stuff around, and that's creating delays even in the finished good. So yeah, this picture captures it well. Silicon is cut into wafers, in this example in Japan, then it's produced in Austin, Texas, into a bare wafer, a fab, and then that's cut and sorted, then it's shipped back to somewhere in Asia for assembly and packaging and test. It's often put into consumer electronics in Shenzhen area is a big area, and then it gets put back to the U.S. as a finished good to go into Walmart or wherever people are buying it. And you can just imagine how long just the shipping takes, let alone, most people wouldn't imagine that it takes 90 days to build up a wafer.
Yeah. Dr. Chen, can you speak to this diagram a little bit and how you see this from a supply chain point of view?
Yes, actually, what David explained was perfect, and I just want to add it a little bit more. So, from my perspective, the supply chain for semiconductor, the chips, is extremely unique. And then, first of all, the barrier for entry for this industry is extremely high. So, right now, only a very handful of suppliers, their supply manufacture most of the chips in the world. So two of the largest one is Taiwan Semiconductor and Samsung. They make 70% of all the chips in the world. So that's why it's like a house of cards. Very few companies, chip manufacturers, send their products to other companies, putting different end consumer products or cars or other devices. So the barrier, the entry is so high, as David mentioned. It's cost to build a chip manufacturing plant. The initial investment will be $4 billion. Some people will say even above $10 billion. And then not only it's very costly, it takes time, 2 or 3 years to make it to full production capacity, because initially 50% of the chips are not usable. So it takes time to reach to 90% of usable chips. So that's why it's extremely unique supply chain, and then controlled by very few players. And then can you go back to the last?
Absolutely.
So you can see.
Sorry.
No problem.
One moment. Let me try again.
Yeah, so you can see that for chip manufacturing, we have the company specialized, Taiwan Semiconductor, on manufacturing. And also we have two companies, they do chip design and manufacturing, both, and then Intel and Samsung. And then, so these a few companies, they control large market share. And then what I thought that's very unique to the semiconductor chip industry is, if we look at upstream, so for lithography equipment, which is critical for making chips, even fewer players in that category. And then so we only put one company there. It's a Dutch company from Netherlands, ASML. So they make the equipment for almost all chip manufacturers. So it's almost like a monopoly. So you don't see this in other supply chains. So that's why, to tackle the issues in chip manufacturing supply chain is quite different from other industries.
Maybe I could, while this slide's up, make a couple points to add to what Dr. Chen said. So it's billions to invest. This is a big boy game. Okay, so this is a lot of money. So therefore, you would think they would just expand capacity quickly. But if we go back to the practice of supply chain management, when things are normal, these end user segments, people are getting demand forecasts for PCs, wireless phones, cars, and then they're lining up their production for those demands. When there's disruptive events and there's scarcity, like when there was the tsunami in Japan, there was an event or others, or COVID, people panic. So if they can't get enough parts, they add a little to their demand, and then they add a little more. Now, maybe demand's 40% overstated or 30. Well, now, do I invest billions for demand that I think is overstated? Okay, I'm going to wait, so I'll lift prices. So the next wave that we'll hit is we'll get through this part shortage and we'll feel material inflation. And why do they do that? If you look back at the stock price of most of these silicon companies, it's feast or famine. Okay, they're either in scarce environments, or it's like selling plane tickets. Once you're flying the plane, you know, the marginal cost of selling a ticket is what drives your pricing thinking, and that's how these guys are. So I think Dr. Chen calls it the bullwhip effect, but the sales and operational planning process right now is out of kilter because of all the scarcity and the buffering going on. And it just gets compounded by the dollars, the checks people have to write to address it.
You know, David, I like to think of this as the toilet paper problem, right?
Yeah.
When the pandemic hit, I stocked up on, got a year's worth of toilet paper. It creates a panic. We have a shortage. I mean, it's kind of almost a pandemic type response, right? So are we seeing that type of hoarding and that type of panic behavior in this market as well? Dr. Chen?
Yes, definitely. As I said, you know, Chinese telecom giant Huawei, they are hedging for the ban from U.S. Government. So that's why they were stocking up a lot of the chips, because in general, Chinese chip manufacturing falls behind, you know, Western countries, U.S., West European countries, and Japan. So that's why, you know, yes, Chinese chip manufacturers can produce some chips, but the high-end, really advanced ones, they still rely on import. So definitely you see the hoarding. Just one company's hoarding can impact, you know, the shortage, the supply for other companies. And then I do want to add a follow-up on David thing, because he mentioned the SNOP, you know, sales and operations planning. So that's a concept we teach in our supply chain classes. The idea is, so SNOP is the process. You know, we try to bring all together all the business plans within the company, such as customer planning, sales planning, marketing planning, development, manufacturing, sourcing. So into one integrated set of planning, so we can have a good game plan, so to help manage, allocate the critical resources to meet customer demand. But I know David wants to use that term, and actually he inserts inventory in the term, like SIOP, Sales Inventory Operations Planning. You know, I think the inventory in this case in semiconductor industry in the current situation is critical. So David, do you want to explain a little bit?
Yeah, inventory is your buffer. So just like Karen gave her inventory for toilet paper, she didn't need all that toilet paper, well, I would hope, all at once, but it was, you know, forecasting and holding it. And there wasn't that much of a cost to hold inventory. But as a company, inventory is a working capital cost, right? It impacts your cash flow. You don't want to tie up cash on that, because that means you're not investing in R&D or acquiring companies or investing in marketing. So ideally, and this is particularly true in automotive, the number of days held of inventory is very tight. The automotive industry, you can count inventory in days, 45 days here, 90 days here. It's a very lean. So now when you're talking about such a long lead time for new production, but very lean, not a lot of buffer inventory, you can see how fast this thing gets disrupted. The other thing, unlike toilet paper, these things have a life. You know, they're packaged, they're seals. You have to worry about the quality of them. And then you also, you know, you're always fighting Moore's Law. So some of you I know are engineers. So Moore's Law was, you know, the concept that you would double the number of transistors every 2 years on a chip, which means computing power goes up, cost goes down. So if costs are going down 20% a year, why would you buy high and sell low? Okay, so you want to do the opposite. Conversely, you know, if you need more computing power because your current product doesn't have voice, but you want to add Alexa to your next product, you need the next generation chip. So you don't want to hold, it's not like toilet paper, you know, doesn't change every year. These things change. So one of the reason, you know, I've been a big proponent of getting the College of Engineering and the College of Business and Supply Chain more integrated is in HARMAN, we need very technically adept procurement and sourcing people. You're not just buying a commodity, you're buying the brains of your product, and that requires a good collaboration. And I think that's true for innovators and startups too. This isn't stuff that you really want to mess around with and get wrong. And we haven't even gotten into the future topics of cyber and some other things we'll do. But it is inventory that you don't want too much of.
Yeah, David, I want to report a fact you will be very happy with. So in every intro to supply chain class I'm teaching right now, so I have more than 10 engineering students. They're in this class, so which is really good to see. And then, yeah, like I just follow up on that. You know, inventory. So in supply chain, we talk about lean manufacturing. We talk about just in time. So in fact, just in time is a philosophy a Japanese company, Toyota, implemented it first, and then other companies are copying them. And then, but after the pandemic, now look at Toyota itself, who introduced the just-in-time. The essence of just-in-time is zero inventory or minimum inventory. So even Toyota is adjusting their practice. In fact, you know, Toyota is the auto company that least affected by the auto chip shortage. You know, I think that's has something to do with HARMAN. You know, David, can you explain what Toyota is doing with their chips?
Or a Toyota or just industry
yeah.
in general, maybe
Yeah.
a broader like automotive. What is the automotive industry doing?
Yeah, well, they're go ahead, Dr. Chen.
Yeah. Actually, from what I read in the article, Toyota actually asked their suppliers to stock actual inventory for a few months. Actually, it's in the articles. Yeah.
Right. Yeah. So what happens in the industry is we might have, say, a month or let's say 60 days of inventory in hand. And our customers, particularly in automotive, they audit our plants, they audit our processes, they audit our work streams. And their procurement team might say, how many days inventory do you have of finished goods and buffer? In crises like this, they'll ask us to lift that. And you know, and it's, on the one hand, you'd say, well, why not? But you get back to, well, it's cash. And then, you know, when demand drops and you're trying to make payroll for employees and people are doing this, there's always a scarcity for cash. So it's not an easy, you know, thing. Inventory is a necessary thing, but it's a Band-Aid to bad process is why I throw it into SIOP. Because if you don't have good demand planning, if your volatility of your revenue forecast is high and you don't want the bullwhip, then you need a lot of inventory. If you're really good at forecasting and you're really good at materials management, you don't need as much inventory. So, but in essence, the industry pushes that bullwhip through the supply chain saying build buffer because we need to smooth out the fact that supply and demand are imbalanced.
Anna.
There's so many things that I want to ask. I'll try to ask one at a time. So the first one that comes to mind is, because in the world of design, Internet of Things is the buzzword now. So everything that we're doing for the future has IoT in it. So the first question would be the obsolescence. By the time that you fix the process, there's another demand. So you're responding to a demand that it's already changed. So how do you tackle that? Or if you two could talk a little bit about that. And the other thing would be, if now this happened, is there any big lesson that we can learn in all our fields to not to repeat it? So I don't know who wants to answer what, but those are the main things that I would like to hear.
I'll take the obsolescence one first, because that one, you can think about this in two extremes of an industry. So particularly if you're an innovator and you're doing something in consumer electronics, you don't worry about component obsolescence, because more than likely you're not the manufacturer. You're designing the user experience, the industrial design of the product, the features, the brand, and then you're finding an ODM in China to make it. An ODM means original design manufacturing.
Yeah.
So they're doing all the stuff that you as a startup might not be good at. They're going to do the hardware design, setting up supply chain, ordering all these parts. And all you probably care about is, I need these features in my product. I want voice, I want these LED drivers, colors, and they figure out, okay, that requires this chip. But in consumer electronics, the life of a product is what, 2 years, 4 years?
Yeah.
Not long. Now go to so your obsolescence risk is actually finished goods, meaning you've overproduced too many products. You've put them in your warehouse ready for Best Buy and others to sell. They're not selling, and you have inventory obsolescence risk, which is bad because finished goods cost more than, components. Now you go to an industry like automotive, and it's the complete other extreme. I'm worried about technology obsolescence even when we pick a chip. And this is why I've pressed for more engineers in supply chain. If it takes us 2 years to sell into a new car, with another 2 years to develop the product with 4-year production life. So whatever chip is available today, we don't want, because by the time we sell it and everything, which means we're picking off roadmaps and A samples and qualifying so that we're not obsolete, okay?
Yeah.
But then in the automotive industry, we have a 15-year guarantee for spare parts. But the silicon industry doesn't want to make these things for 15 years.
15 years.
So we have to contractually worry about end-of-life notices and designs. So yeah, the very extreme edge cases of how obsolescence is thought about. Obviously, for most innovators, they're pushing the fast cycle.
Yeah.
But for entrepreneurs, for intrapreneurs in medical, aviation, automotive industries, they're going to be worried about obsolescence from a technology and software reuse standpoint.
So what are the lessons to be learned? Silence in the audience.
Maybe the lessons learned, let's come back to that question after one more topic of interconnectedness. And I don't know if it helps to put back up that diagram or not, but pre-COVID, there was another disruption going on that I want to hit at. And this, I don't mean this politically, it is what it is. I find, like most innovators, it's fun to connect design, technology, marketing, but in most of our businesses, governments also dictate how things are done. So if we go back to the global page, the one with the supply chain, and you look at this picture, if you recall back the tension between the United States and China and the trade tariffs, okay, tariffs created some disruption because if everything was being made in China, people were scrambling to make things somewhere else. Where could we move production? Can we move stuff to Mexico, et cetera? So that created a disruption just to minimize the tariffs because, you don't want to have to pass that through to the customer. So now you have a supply chain disruption going because all the capacity of the ports and the rail, that was being disrupted. And then it got a little more nuanced when there was a ban that, US companies can't sell to Huawei. Well, that hurt some ingredient brands, meaning within these SoC, there's other components like RF front ends and stuff, particularly in mobile communications. This is all US technology. Well, now they can't sell it to Huawei, but Huawei decides, well, then they're going to vertically integrate. Well, then wait, that actually hurts our long-term competitiveness. It doesn't help. And all of these were for cars being produced in Alabama and South Carolina that are going to the world, because SUV production's all in the United States, even for German OEMs. So the interconnectedness of the supply chain was set up when we believed the world was globalizing. Now, if you
Good choice of words.
look at Brexit and others, if we're not going to have a global, the lesson learned is you got to set up resilient supply chains. And resilient supply chains means you can handle natural disasters, you can handle geopolitical shifts, you can handle these things, but it's easier said than done, because everything that you do, like dual sourcing or anything, is like insurance. There's a cost, there's a premium to having insurance. And I think right now we're in a very disruptive environment because everything's moving in all three dimensions of that chessboard. So resiliency is the lesson learned. And how to think about supply chain risk on a multidimensional chessboard is the name of the game. And the companies that figure that out will have a competitive advantage.
One thing that I'm considering right now, because I love the concept of the 3D chessboard, I like the graphic that you all have that show how interconnected this entire system is. And so I'm thinking of our students who are studying maybe something outside of engineering. Maybe they're studying marketing. Maybe they are in ag in some way, shape, or form. And I'm thinking about how easy it is in undergrad to stay in your group, right? Communicators stay with communicators, engineers stay with engineers, and so on and so forth. But this is really disrupting that. Could you speak to the importance of semiconductors, supply chain, and how people outside of engineers can use takeaways, the things that we're talking about, how can they incorporate it outside of engineering, if that makes sense?
Absolutely. You answered the question by saying every function needs to be interconnected to the other functions for the business to work. And it's easier said than done, because marketing tends to report to a marketing person and procurement. But in the end, our customers here, our supply chains here, and a company's value creation has to be interconnected. And the best example is it's so easy now to sell online. Consumers are buying more online. Online sales are going up. Well, those are often marketing roles, digital. They do search engine optimization, and they just assume if they can turn up the dial to drive search engine optimization and create more sales, somehow there's infinite capacity behind that to fulfill. And when e-commerce was kind of a +1 to the original in-store forecast, it wasn't treated holistically in that S&OP process. Well, now it can be up to 60% of the business. It's like its own store. So, people in every function need to understand that there isn't an infinite water spigot that you just turn the dial and it instantly turns on, or like our light switch. These are long, complicated supply chains. So if your brand reputation is all around delivery excellence, every function needs to understand how to work with the others.
Yeah, that's a good way to look at it. I see this as a differentiating factor for our innovators, for our undergraduate students. Even if you're going into marketing, if you're in an interview and you can explain the supply chain process for the company in which you're interviewing for, that's a huge differentiating factor than just saying, well, I know these marketing principles that are important, but I also know the inner workings of how we function as a company. This is all great. I'm incredibly excited, and I'm taking some notes too about how I can start incorporating this into my own life, honestly.
Yeah, I think you asked a really good question. As David said, cross-functional collaboration, that's easiest to be done. And not only for students, you need to pay attention to people in other field and then be able to work with them. Even for companies, within companies, in supply chain, we have a term called the Great Divide, which means within the firm, different departments, they don't align their goals, objectives with each other, as David mentioned. So sales department, marketing department, their goal is to create more sales. And then, but for sourcing production, their main goal, the performance metrics is on cost, saving cost. So when you have different goals, the companies, definitely departments or employees, they will work for different directions. So not only for students, as I said, for companies, it's also a challenging task to align all different departments together to collaborate with each other.
One of the things we've talked about on this, and I've heard a number of speakers, I like hearing what's consistent across speakers, is that good innovators are naturally curious. Different people have used different words, but in essence, they're curious how things work. They're curious to the attention to detail of, well, if I'm successful in selling something, how do I fulfill it? And how does that work? So, the takeaway, hopefully, to what you're getting at, Nakaya, is that we all need to be more curious, and then we all succeed better, because it's more than just doing in your lane. It's understanding how things are interconnected. Everything right now is interconnected. And the geopolitics is one, but I was, listening in on, I was at a Deloitte conference for CEOs and M&A, and Ben Bernanke was one of the speakers, and he was talking about the interconnectedness of economies. But the CEO of Deloitte was talking about the next biggest wave is digital, cloud, and cyber. And, if you think about everything in our life, we can tell our oven to turn on through voice. We can use a mobile app. We can wave our hand. Everything smart is convenient. Everything smart can be disrupted because of cyber. And now the next big thing, and the statement that caught my eye, is the next COVID-19 disruption in the world won't be a human virus. It will be a silicon virus.
Yeah.
And it will disrupt us like we don't know. And I think we're just at the infancy of preparing. I'm a huge fan of what Iowa State's doing, because what Doug Jacobson's doing and the software engineering is really hitting this head on, because this isn't about like the IT department locking down a USB port or something. This is getting into how, when that silicon is made and firmware is put on that chip, who touched it? How do we know that the code that they put on didn't have a back door? So now you're talking about supply chain resilience of cyber engineering. And that is really, when you pull all the trade dynamics aside and you really look beneath the cover, the real issue on this trade dispute is a cyber dispute. And it's around privacy and rights, and what are we going to do with all this in a world of AI and connectivity? And that's what really is the fundamental thing, and it's real. If you really look at, it's fascinating how convenient these things are, but the more reliant you are on the convenience, the more disruptive it can be.
So David, what conversations should we be having now as we consider some of these issues? Where should we be going, and what should we be diving into? I'm even thinking from a student standpoint, if they're really engaged about the problems that you've posed given this situation, where are they headed next?
Well, if I were a student, and particularly an innovator student, I would think about Wayne Gretzky's comment: skate to where the puck is going. Okay, not where it is. And the where the puck is going is in cyber, is in AI, is in robotics. So these are fields that you're going to have a good, challenging, lucrative career in. And it doesn't mean you can't be a marketer, you can't be in supply chain, right? I think first you need to think about those industries and trends that are going to create exponential growth. And then what's your role in those areas? That would be the simple answer. Skate to where the puck's going.
And could we also say that, hinting a little bit to what Nakaya was saying, that we need more interdisciplinarity, cross-disciplinarity, whatever, transdisciplinarity, whatever is the prefix. But that brings me to a thing that Nakaya and I were in training this morning. One of the qualities or one of the competencies of future innovators is then this systems thinking operation mode, like understanding that it's not just your node of your discipline, but knowing that you need to learn more about other things. My question behind this is, are we saying that our innovators need to be more of generalists than in-depth experts? Or how can we deal with this? It's a big question in education, I'm sorry.
I can only share you my personal school of thought. I think the world's too complicated to have generalists, okay? Yeah. But I think it's also too important, interconnected, to have one-dimensional experts, which means you got to think about building expertise in every role you're in over multiple roles, multiple expertises. Okay, you have to over time become, left and right-handed. What do they call that? Ambidexter.
Yeah.
I believe that you can't be superficial. You can't just walk around and say, "Well, I've heard the word supply chain and AI and robotics and get by." But on the other hand, if you can only do one thing and you don't understand how things are connected, how do you get there? So, you might be a great engineer that can write the coolest app, but if the HMI is awful and consumers don't adapt it, there's no demand, okay? You could be the most creative artist having the coolest user experience, but if you don't know how to make the thing, there's no fulfillment of demand. So in the end, it takes a team. And that's why, I know the advisory board for the College of Engineering, we keep wanting the X factor from students beyond their academic education. And that X factor is team skills, interdisciplinary work, how to solve problems, critical thinking, all the stuff that goes on top of the education.
I think that's a fair assessment. And basically, David, what we're saying really is it's no longer really a great skill for people to be in the box, in their own, a subject matter expert. So now there's another level. Subject matter expert, absolutely be excellent in your contact area, but there's another level of development and engagement. I would say two levels. One, you have to create some informed technical awareness, right? Of all those things that are touching your field. And then there's the behavioral capacity elements. You also have to build those behavioral capacity elements. How would, you've been involved very heavily in, as an advocate for student development as innovators. How are innovators charting their course? How are they charting their educational pathway as you think about technical expertise? What are some of the other must-haves?
The curiosity is one that I think is a common characteristic. When you had Bill Gross on 2 weeks ago, all he exuded was, I was curious about this. I went deeper into this. I was curious about this. Okay. The second would be bold. Okay. Courage. You have to balance being a perfectionist and being bold. And what's often difficult is, straight A students are perfectionists and the academic system treats you to be perfect. But then how bold can you be if you're always trying to be perfect? How comfortable are you with risk if you're always trying to be perfect? So getting comfortable with being uncomfortable is another trait I find as innovators. Put yourself in experiences where you're uncomfortable. So, some of you know I'm a proponent of helping Team Prism, the solar race car team at Iowa State, and it's primarily engineers. but I've brought some business students in because, my belief, and my son's one of them, he wants to be in business, he wants to be an innovator, and I'm like, well, you won't be successful if you don't learn to work with engineers, and it's not the easiest thing to do, so join a club as a business major and learn to work with engineers on something like Team Prism, because then you learn those skills naturally before you're in a work environment and you don't have the, there's less time because you got to deliver. So those are the things that I think, things like the innovation program, the startups, the experiencing hands-on, that really differentiates it. And you don't have to pick. The other thing to look at, back to the generalist, is, let's say a generalist is only 5% deep in a lot of things. Well, when you're in something, go to 100%. Now, the next time you go to 100 and you go to 100, over time, you're only 20% deep, unless you have a supercomputer memory. But still, if you're 20% in everything you ever did and you forgot 80, you're still 15% more than somebody else. And when you meet people like that, it's evident.
Yeah, I think you bring up a very important point about it being evident. And when you meet people like that, it's evident. I think part of a brand of innovation is, what are you known for? What qualities are you recognized for? And so I wonder as well, I'm sure both you and Dr. Chen have come into contact with people as innovators where it's evident that they have a specific brand. They're doing some specific things that make them those people that are memorable and evident. Can you share a little bit maybe about those things you've observed that make people memorable and evident as innovators, and people that you'd want to lead with and collaborate with?
Dr. Chen, I'll let you go first.
So you're talking about individuals or companies? Because what you said is also very true about companies. Any company, you want to be known for something. That's what we said. It's your special core competency. Apple is known for their design and new product development. Nike is the same way. So each company wants to be known for something. And then, so you're asking about the company or individual level of innovator?
I think that I think both, actually. So okay. I like that you're pointing out that even this manifests on a corporate level. What are we known for? How are we designing our pathway? But also individuals. What are the things that stand out to you? Because I think our students are looking to, go that pathway. They want to do what I call, there's the hard skills and the harder skills, right? So what are the things that they should be looking at to be known for if they want to contribute meaningfully?
I can share one that I know you feel in companies, and I see it in students that we're interacting with, okay? It's just evident, and that is the ability to have contagious energy, okay? If you have an idea, but you can't get other people to buy into it and believe into it, then your ability to get a team that's required to success. So, innovators have this ability to attract people to the challenge, a contagious energy, and willing to take risk. And you heard that from Bill Gross, you hear it from some of the students we hear with. So, but what's also important is when you meet people who say, okay, I'm not naturally that way, so I'll find somebody on my team who can complement me to do that. So, that self-awareness would be the second thing I've noticed innovators have, is they're really authentic to finding complementary skills to complement what they have. And then I'll just repeat boldness, the ability to make quick decisions and balance gut with data. And that's, if any of you read Steve Jobs' biography, I think there were two things that, I'll never forget out of that big book that was that thick, but it was that he trusted his gut and then this reality distortion field comment from his people. Those two are combined, right? He not only trusted his gut, but he could distort reality and get everybody to believe it because he was distorting it. And that's a skill that is unique and you see in innovators.
As
You know,
for,
I
I
want
have
to
a
bring,
question.
go ahead, Kaya.
So I have a question about that specifically, but a step further. So I think with the young innovators, a challenge can be wanting to trust your gut, wanting to trust your skills and your abilities, but also wanting to respect the fact that there are people who've been doing this longer than you. How do you balance taking feedback and criticism as a young innovator and showing that you're willing to grow, but also dominating and being bold? What does that balance look like?
Test, test, test. So we've talked about how innovators need to develop a minimal viable product or service and test, test, test. Well, that's no different than when your gut. So if your gut's telling you something, it doesn't mean you blindly follow it. It means you start testing it through experimentation, networking, dialogue, listening to feedback. On the other hand, if everybody's giving you that, there's a lot of, I'll call it superficial noise in the media and the hype effect. And most innovators go against the hype effect, right? We heard, again, Bill Gross said that. It resonated with me because I think it's so true. So having that courage to listen and test, but the conviction to know, no, you have a deeper insight than that wave. And I was talking to one of I don't want to say who, but one of the people out of the Papa John's contest last spring, I thought was a cool business. So I called up the student and said, hey, you mind if I talk to you and just help you out, as a mentor? And that was his big question is, I know I'm right in what I want to do and I listen to people, but I have to throw out half the noise. Is that right or wrong? And my feedback to him is it's right, because you're listening, you're being inclusive, but your insight's deeper than theirs, and they're just giving you that noise. But it's a constant journey, and I think most good innovators will make it a personal struggle. You don't want to be so arrogant you don't listen, but you got to have enough confidence to trust your gut. Another story on that I went through, because some of you might know, the reputation of Chicago MBA is all quantitative. Okay, so as an engineer, I went to Chicago. I thought, hey, this is a natural home for me because it's all analytical, it's all data. And they even had a class about not gut and mismanagement, only use data. And I started working for, a guy I worked for, known for 25 years. And he would say, well, I don't agree with your analysis. My gut says the following. And it just threw me. The first time he did that, I was like, oh my gosh. And then I realized, wait a minute, any model, I could play with the inputs or the outputs and kind of play around with it. So instead of debating them, I would just go back and say, what would I have to believe in the inputs and the assumptions to make the model prove his point? And 70% of the time he was right. And I would go back to him and I'd say, hey, I played with this. You're right. Here's why. Here's this. Then 30% of the time I would be playing with it and I couldn't do it. And I'd be going back and he'd say, hey, before you say anything, I think you were right. And we bonded over that kind of collaboration. And I think that taught me that, hey, you can manipulate numbers, which means as a leader, particularly in M&A and other things, in diligence and valuations, you really got to believe in that balance of using the analytics, but trusting your gut. Trust that deep insight. Do you have some unique insight that makes it work or not?
May I jump in for a little
Please
bit?
do.
Yeah, because I think Nakuya asked a really good question. I had the similar question from my past students. So when they graduated from Iowa State, they joined company working supply chain area. And then sometime later, some of them came back to me saying, I have a new idea about implementing a new process, but it's really difficult to have my colleagues or boss to buy in the idea, but I just don't want to be rude. So I think that's very similar to what Nakuya was asking. So my suggestion to them was exactly as David said. You need to respect them, that's for sure. But on the other hand, you need to show them numbers, show data. As David said, test. If you can show convincing numbers, statistics, your suggestion will have a positive impact on the company's supply chain management operation. they will, be more likely to accept your suggestion. So I think that's my like additional point to add on what David just said.
I want to focus on the fact that basically you are both stressing the significance of getting people to believe you. And it occurs to me that being an innovator is the territory of evangelism, right? And the danger of an evangelist is to get caught up in your own head and your own beliefs about the world as people follow you. So that necessity to test and be real and be true and check things out is really important. But I do, this brings us back to the territory of the reality distortion, right? In some sense, an innovator has to be willing to look at being a reality distorter. And I'm going to come back to the semiconductor here, because in a sense, we're held hostage to the semiconductor, right? And because we use it for everything. So what is the next Steve Jobs, the next reality distorter, talking about when it comes to the semiconductor? Where are we going with this, and who's leading us?
So that's an interesting area. So, there is a concern in the industry that we're approaching the saturation of Moore's law. Okay, so this doubling of computing power having a cost is coming toward an end because, how many transistors can you get in, we're talking about now 7 nanometer processing. The manufacturing process now at the forefront is 7 nanometers. Try assembling that, okay? It's mind-boggling. So the next gen of moving beyond transistors, which are, basically a switch, is what's called optoelectronics. And in essence, that to re-jump on the Moore's laws, it would say, well, what's faster than the speed of light's the fastest thing, so let's use optoelectronics, let's go faster because you're no longer having a switch, but it's light. But it has its own things. I think what will happen though, and again, I'm going to use the energy vault example of, hey, who would have thought stacking blocks up a crane, but kept driving the economics. What would drive the economics? What would make it work? And that's what will happen next in the silicon energy, because we're going to consume more and more of this. A second area is, when we look at our SoCs for an automobile, it's, there's, of course, amplifiers and the things that make great sound and great speakers, but the forefront of it was everything you're doing in the car for navigation, your touch screen, your navigation.
Right.
Well, those were basically the level of computing of a phone or a laptop. So there was a CPU and a GPU, a CPU meaning the central processing unit handling all the numbers, and a GPU, a graphic processing unit, handling all the imaging, like in your Xbox. But now there's a third building block that's growing fast, and that's NPUs, neural processing units, because of all the AI and analytics that are going into these, particularly for self-driving cars. So now it truly is the brain because it has an NPU. And that whole area is a fast-growing area. And then, of course, you have to put all the embedded software and do all that, and then make sure it's secure. So now how do you make sure it isn't hackable? And I don't know, maybe if that's a good place to run our little clip to just give a sense of how real of a consequence this is. If Spencer wants to try that, have a little fun here.
Yeah, so as we look at that, so your point is that looking at the future, David, we really have to be thinking about this cyber issue as it relates to this. That's really where we're looking. Go ahead, Spencer. We can.
Come on. It's zombie time.
She opened up saying hack it all if you didn't hear that. Hack them all.
I'd buckle up if I were you. Safety sensors overridden. Thank you.
So, thanks, Spencer.
Thanks, Spence.
So look, it's fun, you know, I don't know, I assume people have seen that movie. There's several movies, but if you step back and think about the ethics of this, right? Your water supply, the imbalance of water treatment plants, the power grid, security systems, everything in your home. If these were vulnerable to a COVID virus, the way our human body was, imagine the disruption economically that would have. So you know, you could argue the amount of investment that's going into this area is insufficient for resiliency. So the lessons learned on resilient supply chain should be resilient technology, okay, in the face. Imagine that, you know, there's a silicon chip for a heart, what are they called? The thing that makes the heart beat, right?
Pacemaker.
Imagine that that gets hacked. So you know, we should, you know, I always feel like you go back as a kid, everything in science fiction movies when we were a kid is now a reality. Okay, the communicator in Star Trek. I now have my Samsung flip phone. You know, it's my communicator. There's medical devices. We're putting out RCP platforms, remote care platforms. So, you know, all of this technology is convenient, but it has to be secure. And I think that's a growth area that it can intrigue many functions, not just engineers.
Absolutely. One common thread that I picked up throughout this conversation is anticipation, the mindset of anticipation. My question is, what are some things that students could start practicing now to get them in the mindset of anticipating what's next? They might not be working for a multi-billion company right now. Maybe they want to work for one, maybe they want to own one themselves. What are daily practices or questions that people can be asking themselves to take it a step further? Not just settling with what you know, but anticipating what happens next.
You know, you almost answered it, daily habit. So I'm a big believer in this. So a daily habit I have is I like Flipboard, and then I have lots of blogs, and one is cyber. So my daily habit is reading about cyber every day because it's accumulated knowledge. I'm not going to become a cyber expert. That's not my area of field, but I've learned enough by daily reading. I made it a daily habit. Another one is on private equity because, you know, I'm not a finance guy by background, but every day I can have accumulated knowledge. And then those spark curiosity because I might read something and say, whoa, what is this? And then you go Google it. So daily habits of consuming information is, I think, you know, make time to think, time to learn, not just do every day, because you can't plan it. It's not like studying for an exam and cramming. It's this accumulated habit.
Yeah. Dr. Chen, what about you?
Actually, I think that's a really good question. What I would say is even more preliminary than what David suggested. It's a daily habit, but actually I always encourage my students read. Like you don't have to read extensively about every day's Wall Street Journal, but I do encourage them as a business student or business minor, you do need to know what's happening. You know, only when you read daily, as David said, you accumulate knowledge and then you know what's going on in the market, particularly for the markets that's related to your area. And then you can have a good anticipation. You cannot develop a good anticipation in isolation. You have to know what's going on. So, for example, if you're in the chip industry, you need to know what are the new developments. The most recent one I read yesterday was China and US will have a working group meeting face-to-face in Alaska next week on March 18th, specifically talking about semiconductor industry, how these two countries can work together, ensure stable supply of semiconductor chips. So that's, both countries' semiconductor industry associations will send out the representatives. They will meet next week. So, knowing this, that, give you some basis for good anticipation.
I'm going to come back to that comment about discomfort too, because when we talk about, yes, go outside of your field, areas that you have discomfort, that aren't so easily accumulated. I'm aware that a comment we hear from our engineers is, I wanted to do the hardest thing. And that type of spirit, that's also a type of resiliency and a capacity to tolerate being uncomfortable, being in territory that's unknown. And so I think that you two bring back both a very important thing about maybe students, the habit that's required is for students to find opportunities to go beyond where they are normally comfortable, which is why I just want to end with a little note about this. I know we started this conversation because we said, and I said to you, David, well, why do we want to talk about semiconductors? Only a small part of the world, only a small part of students are going to be caring about this semiconductor thing. He said, no, that's where you're wrong. Because again, this is part of a broader conversation, right? So any last words about, as students go into the world and are thinking about habits, being uncomfortable, going and experimenting with other things, where might you think the next, beyond semiconductors, what's the next major area for innovators that they should be immersing themselves in?
I guess I would close a little with where you are right now. If I'm an innovator in a startup and I'm thinking about getting the product out, I'm thinking about engineering, design, etc. But think 3 steps ahead. Assume you're wildly successful and prepare for it. Then I need a supply chain person on my team. So I think, often people are so focused on the wall in front of them that they got to get through. They're not thinking about the next and the next and the next. And if you just assume success, 20% of your time, of course, 80% of your energy is focused on the hurdle in front of you, but scenario thinking 3 steps ahead, that's an important skill for innovators. And then that'll take you where you need to go and find complementary team skills.
I want to thank you for your time today. Nakaya, did we have any final questions?
No final questions in the chat, but I do have one for both David and Dr. Chen. What excites you most about the next generation of innovators who are coming into the engineering industry, who will lead in future conversations about semiconductors? Based on their current characteristics and what you all are seeing, how do you think they might shake up that industry? How do you think they might challenge that industry maybe 5 or 10 years from now? I know that's a loaded question, but I'm interested in hearing.
Go ahead, Dr. Chen.
So actually, I wanted to make a comment as like a final comment. I can use that to answer Nakuya's question. In fact, in supply chain academic area, that's the most cited quote in all supply chain literature. Actually, is a sentence by Martin Christopher, who is a well-known scholar in UK. What he says is, today's competition is no longer between companies. Today's competition actually is between supply chains. I think that's a really important mindset for any innovator to keep in mind, because you have to understand, developing a good prototype doesn't ensure you get a success. You have to think about, we talk about this, understanding the supply chain. You have to assemble a good supply chain to compete with other supply chains. So I'll use this to answer Nakuya's question, is what's exciting to me is to see our students in different majors, they can work together, to develop a supply chain not only a mindset, to solve issues from a supply chain perspective.
That's fabulous.
I'm always energized now by the students' maturity and ability to connect and be bold enough to change the world. I'm happy to see the me generation kind of disappearing, because it's all about the finance, it's all about making money. That wasn't the innovators world. And now I sense this, hey, we can change the world. I don't like all the polluting products. I want to drive innovation or reuse. So I'm always fascinated by the boldness and the courage and the maturity that students have today compared to, when I was in school, it was, where are we going to be Friday night? So that's exciting. It's really come a long way. It's in an earlier stage than I think it was prior. And that's fascinating.
Yeah, I really love what you're saying there. I keep teasing the students that the new BA is actually big asks and bold action. That's the new BA that you want, right, from your university. And so I think on that note, that's it's a grand invitation for students, and we see it happening everywhere. So I want to thank you, David Slump, again. And also for your ongoing contribution to our program. And you invest your time, your energy, your mindset, you collaborate directly. Really, you have done our university a service above and beyond. You're innovating us and with us. And it's been profound. And Dr. Chen, thank you also for your time and your engagement of All In, and your sincerity and commitment, especially to looking not just about teaching your discipline, but really thinking about how can we help evangelize this cause. And I'm looking forward to further connecting you with our innovation cohort. Nakaya, thank you so much. And also, I will say, this connects us perfectly. Speaking of big asks and bold action, next flagship Friday, next week, is Lewis Carr with Black Entertainment Television. Someone saw something in me and did something about it. And he talks about how we as innovators have to really think about seeing something in the world around us, but also in each other, and then doing something about it, about the action, the bold action part. And he is the epitome of bold action. Nakaya, do you have anything to say about Lewis Carr for next week?
I do. It's going to be a wonderful conversation. Lewis brings this fire and energy with him everywhere he goes, similar to what David talked about. So he's probably going to share a lot of personal experiences, he'll give you a lot of insight on things that he's learned throughout his journey from a very young child to now being a president of media and sales at BET. So it'll be a great time.
Yeah, I'll never forget Spencer writing me and saying I fell off my chair when Lewis Carr said, when somebody asked about how do we bring ourselves to work, and Lewis Carr said, why would you ever want to bring yourself to work? That's not the self you want at work. And that was such a, if you want to be surprised by being someone who's audacious and bold, be prepared, strap in, and get ready for next week. So thank you too for this week, and we'll see you Innovation Anywhere. And thank you for innovating with us.
Thank you.
Thank you.
Bye, team.